Guys, chapter 12, Stoichiometry Calculations. So let's look at what calculations are we going to use. All right, the first thing is you need to know is number one, write it down, 1 mole. All right, 1 mole of anything is how many particles? 6.02 times 10 to the 23 are the particles. These particles can be atoms or molecules or formula unit. All right, sometimes it will say atoms, sometimes it will say molecules, sometimes it's formula. Okay. And then also you need to know number 2 is 1 mole of anything is the molar mass. Molar mass means the mass of the element, which will be 1 mole. All right. So for example, what is molar mass? Molar mass of water. All right, what is the molar mass of water? The mass of hydrogen, 2 hydrogen, and mass of oxygen combining. So it will be 2 plus 16, so 18 grams is the molar mass of 1 mole of water. All right, so let me write it in a bigger pen. So 1 mole of water is 18 grams of water. That is called molar mass. Okay, so first thing you know is 1 mole is 6.02 other particles, but if you have to weigh something for a mole, then it is the weight of that element or a molecule. Okay. All right, number 3 you need to know is moles are coefficient. Coefficients of balance equation. All right, so you have to have a balance equation, and the number to balance it, the number comes right in front of the elements, are coefficients. So those coefficients are also moles. All right, so you need to know at least these 3 things. All right, atoms, Avogadro's number, molar mass, and the coefficients. Okay, so let's draw a line. And in a stoichiometry calculation, what do you need to know? Write it down, stoichiometry. Stoichiometry calculation. Mostly, first thing you're going to change is from moles to 1 mole to another mole. All right, changing from one kind of a mole to another kind of a mole. So moles to moles calculation using the balance equation. Okay, so that's number 1 calculations. Number 2 calculation will be you're going to do the atoms. If you have atoms, you're going to change it to moles. So what are you going to use from atoms to moles? You're going to use the Avogadro's number. All right, those are the atoms. 6.02 times 10 to the 23 to moles. Number 3, you're going to do the opposite. if you have moles, you need to change it to atoms. Same things, atoms to moles, moles to atoms. These are the calculations. And then number 4, if we have weights of elements in grams, so you have the grams of the elements or a compound, you need to change it to mole. In this case, you're going to use the molar mass, the mass of every element or compound or molecules given. You need to change it to mole. Okay? And number 5 is opposite to that. You have the moles given. You need to change it to grams. All right. Number 6 is the 2 steps process. Grams will be given, weight will be given. You want to change all the way to atoms. In this case, all right, the other day we saw the video, grams and atoms, you have a bridge here. Bridge is going through, mole is the bridge. Okay, so if you have grams, you want to change it to atoms, you go through the bridge of mole. So change the grams to mole first, from mole to atom. So this is 2 steps, the rest are all 1 steps. All right, so 6, and the last one, hold it. The last one will be calculating the molar mass. Calculating molar mass. What is a molar mass? All right, so 7 different calculations. Got it? So let's start from number 7. How do you calculate the molar mass? Molar mass means the mass of 1 mole. All right, molar mass of 1 mole. So the mass of what? So let me give you a molar mass means, write it down. Molar mass is the mass of 1 mole. 1 mole of anything. All right. So let's see molar mass of water. Molar mass of H2O. So what will be the weight of H2O? $18 grams. How do you get 18 grams? 2 hydrogen is 2, 16 oxygen, so total is 18 grams. All right, let's see molar mass of copper sulfate. CuSO4. Go ahead and calculate this, please, by looking at the periodic table. So copper, where's copper? Right here, round it up, 64. All right, so copper weight is 64 plus, find the sulfur weight. Where is sulfur? Here, 32, and 4 oxygen. So oxygen is 16 times 4. So what will that be? That was fast. 160 grams. All right. So 160 grams of copper sulfate will be 1 mole. Got it, guys? So anything with the formula, you have to edit all the weights from the periodic table are 1 mole. All right, that is also called molar mass. Got it? So now you have the grams, you have the mole. All right, the problems, if you look at it, you can change the grams to moles, moles to gram. All right, using this conversion. So let's go and do the mole to mole conversion first. Number 1, mole to mole calculations. So let's think about one kind of a mole changing to another kind of mole. So what will you need? You need an equation. So nitrogen plus hydrogen, you are making NH3, which is ammonia. So this is an equation. But is it balanced? No. So the moles are the coefficient of balance equation. So balance this one, please. We're going to find the moles from this equation. So balance it. First thing we're going to look is nitrogen is 2. Here is nitrogen 1. So what you're going to do? You're going to make it to 2. Then hydrogen becomes 6. So you can make this to 6. And this will be 1. So now it's balanced. So that means 1, 3, 2 are moles ratio. All right, 1 mole of nitrogen reacting with 3 moles of hydrogen, you're getting 2 moles of ammonia. Okay? So the problem here is if it is nitrogen is given as 0.35 moles, how much will ammonia be? Can you do it in your head? What is the ratio? 1 to 2. So if it is 0.35, how much will this be? Paul? Paul? 0.7. How do you get 0.7? Twice as much. Or you can write it this way. Whatever given here, you're going to write it 0.35 moles of, you have to write what it is, nitrogen. All right? Now, the ratio of nitrogen to ammonia is 1 to 2. So 1 mole of nitrogen is 2 moles of NH3. Correct? So cancel this out, you got 0.7 mole. Either way, sometimes it's easy to do it in your head, but sometimes you have to write the ratio next to it. Okay? So now you are changing the moles of N2 to the moles of NH3. Okay? So if you have the 2 products, you like to know how much you get, 2 reactants, how much you will get the products. So you should know the ratios and you can calculate the product. Okay? All right, another problem. This will be the equation KClO3 KCl plus O2. Go balance this one, please. So when you look at the equation, K is 1, chlorine is 1, only difference is the oxygen. All right, oxygen is 3 here, 2 here, so it's, you need to make it to even. So what do? Multiply by 2 here and multiply by 3 there. All right, so now oxygen becomes 6, here is 6. So once you multiply by 2, what's changing? Chlorine, potassium and chlorine becomes 2 and 2, right? So where do you put the 2? Right here. So the ratio is 2 to 3. Okay, so let's use the same number. 0.35 moles of KClO3. How many moles of oxygen you will get? Okay, so let's set it up. 0.35 moles of KClO3. What is the ratio? 2 to 3. All right, 2 KClO3, that's KClO3, so the KClO3 will come at the bottom. So this is 2 moles of KClO3 will give 3 moles of oxygen. So what do you do now? Cancel this 2, multiply 0.35 times 3 divided by 2, you get 0.7 moles of oxygen. Get it? So this is changing from 1 mole to another mole by using the balance equation. All right? So next one, let's use the moles to atoms calculation. So it's number 2, moles to atoms. So if you see an atom or atoms like this, you will know the Avogadro's number. You will use the Avogadro's number. So what is the calculations? So the problem is, let's see, 2.5 moles of zinc. Can you change it to atoms of zinc? All right, so 2.5 moles of zinc, change it to atoms of zinc. So 1 mole of zinc is how many particles? 1 mole of zinc will be how many particles? 6.02 times 10 to the 23 particles. All right, or atoms. This is 1 element, so it would be atoms. So let's set it up. What is given in here? 2.5 moles of zinc. So where will you put this conversion now? Where will you put 1 mole? Where will you put the 6.02 times 10 to the 23? Where will the 1 mole be? At the bottom. 1 mole of zinc and 6.02 times 10 to the 23 atoms of zinc. All right, so mole of zinc cancels. Now you are multiplying side by side the 2. If you are multiplying, I need that one. If you are multiplying, what do you do? 2.5 times 6.02, multiply it, and 10 to the 23, just carry over it. All right, that's the easiest way to do. So what do? 2.5 times 6.02 is 15.05 times 10 to the 23 atoms. Now change this to scientific notation. So you need to change the decimal to the left. 1.505 times, you are making it a smaller number, right? 15 to 1, 1.5. So the exponent will be a bigger number, 24 atoms of zinc. Get it? So this type of calculation is changing from moles to atoms, okay, using the Avogadro's number. So let's do the same way. Number 3, atoms to moles. All right, there'll be atoms given, you need to change it to moles. So let's look at another problem. Let's see, 5.75 times 10 to the 24 atoms of aluminum. Now change it to moles. Go ahead and do this. Write it down, what is given. All right, so what will you put right here? Take out your earplug. What will you put right there? Kayla? What will you put here? What will you put on the top? Bottom? The conversion is 1 mole is 6.02 for anything. All right. 6.02 at the bottom. 6.02 times 10 to the 23, this will be atoms of aluminum is 1 mole of aluminum.